All right, everyone, this is, I think, our very last video for content in this semester. So yay. It is not a terribly difficult concept. It just has a lot of little variables and stuff going on. So we need to make sure we know what they are. So basically, it's called determinants. Okay, determinants, determinants. Okay, and what it is we're going to use something called the determinant, which it looks like this comes from a matrix, basically. Okay, and we're going to use this guy to figure out a value. Okay, and sooner or later we're going to use a special rule and we're going to solve systems of equations using the determinants. Okay, so we are basically at the point where we're saying, hey, these are my X's and these are my Y's, just like what we've been doing. Okay, X's and Y's. The A's are like, remember when you did a quadratic equation, AX squared plus BX plus C. Okay, that's what we're looking at here. The A goes with the X's and the B's go with the Y's. Okay, and so the fact that we're on this first row tells me I'm using the first equation basically. So the 1 guys are all going to be 1s because they're the first row. Okay, the 2 guys are all going to be 2s because they're the second row. Okay, so in order to determine that these are, in order to signify that these are determinants instead of matrices, we're going to use these vertical lines around them instead of like the matrix box. Okay, the hard bracket that we have from that. There's this rule that says if you want a value for this determinant, then what you do is you work off of the diagonals. So we'll do this with numbers in just a second. I just want you to know the process. So when it says we're going to multiply A1 times B2, it's because we're working off this diagonal. Okay, so we're going to start top left and work our way down, and we're going to multiply those. Now we're only doing 2 by 2 determinants, but just think if we had a matrix with 3 variables and 3 unknowns, we could do a 3 by 3 determinant, right? Which gets a lot more involved. So we're only doing the 2. So they do this diagonal down, and then they say minus. Start at the bottom on the left and work up this diagonal. So it ends up kind of looking like a butterfly, A2 times B1. All right. So first off, let's just practice with that for a second. I know it's a little bit confusing at first, but once you get a little bit of practice with it, I think actually a lot of my students like these the best because they're like, oh, I just plug it in and it's kind of like having a little formula that just gives you the answer. So here's an example. We're going to say, start with this matrix 5, 6, 7, 3. Okay, the top row is a 5 and a 6, and the second row is a 7 and a 3. And you don't even have to memorize which one's the A's, which one's the B's, whatever. You just have to know, start top left and do this diagonal. And when I say do the diagonal, I mean we're going to multiply, right? So the value for this guy is 5 times 3. I'm going to multiply them. And then it says, so it says multiply, and then it says subtract minus the other diagonal. 7 times 6. All right. So my value here is a 15 minus a 42. And if I punch that into my calculator really quickly, I see that this is negative 27. Okay. So we just get values coming out of these determinants. And what ends up happening is that this matrix right here, the A1, A2, B1, B2, you'll see it a lot. It is going to be called, or this matrix, when I put it in here, it's going to be called capital D for determinant. Okay. So that guy, what we're going to do is we're going to do some special order stuff. And whenever we see a particular ratio, we're going to use this determinant to kind of ground us and say, this was the original. Okay. And then we're going to, in a minute, play with some other stuff. But that's what it's going to look like. So all we're doing right now is doing some determinants and finding their value. Okay. So that's it. So here's another example. Okay. We've got 2 and 4 on the first row. And we've got a -3 and a -5. And all I want us to do is just find the value. Okay, so this is going to turn into my determinant is equal to 2, 4, -3, -5. And when I look at it like that, I say, oh, I'm just going to do that butterfly thing. Okay. So this particular D equals the value for it. I'm sorry, let me scoot up. D equals the value for it. Start at the top left. 2 times -5. We're just multiplying. Okay. And then in the formula, we're finding the determinant value is a minus. Okay. Minus. And then do the other diagonal, right? -3 times 4. Okay. So then I just find a value. Okay. So this is 2 times -5 is -10. Negative times a negative is going to be a plus 12. So -10 plus 12, the value here is a 2. All right. That's it. That's why I said so it looks a little confusing at first, but once you see the pattern for it, like lots of my students really like doing these, okay? Because it's just, oh, I just do top left times the bottom right, and then I change it, and then I subtract, and I'm done, okay? So here, try one, okay? 10, 9, 6, 5. That's your matrix. So first, make your determinant. D equals, put in the vertical lines, make your determinant, and then see if you can find a value. D equals right here. If you need to, pause the video for a second so you can do that work on your own. So hopefully you're there. 10, 9, 6, 5. This looks exactly like the original, right? It's just got the vertical lines instead of the hard bracket. So that's it. Okay. And then go ahead and find your value. I hope you're able to do it. It's not terribly crazy, right? Okay. So when I look at it, I say I'm going to do 10 times 5 minus the 6 times the 9. Well, that is 50 minus the 54. Everybody agree? And 50 minus 54 is a -4. All right. Everybody good? All right, one more for you to practice on, and I am totally, so we've got these, you can see them. I am totally going to pause my end of the video and, oops, work this one out so that you're not going to see any of it. And then I'll come back on and I'll be like, here's my answer. So I would like for you to do a little bit of practice with it and make sure you can do that on your own. So for sure, pause the video as soon as we see the thing. We're going to do the same thing. We're going to write the determinant and get a value. Okay, the matrix is 4, 3, -5, 5, -5, sorry, -8. There's your matrix. Okay, so I'm going to pause my video. I'm going to work this thing. I want you to do the same and come up with what does the determinant look like and what is its value. Okay, so here we are. All right. We had this guy, 4, 3, -5, -8. We made it into a determinant. Our value is 4 times -8. I got that. Minus, because there's a minus in the formula, -5 times 3. Okay. I have a -17. So hopefully that is your answer. All right. That's determinants. Like I said, they look a little scary at first because they've got all those A1s and B1s and stuff going on. But once you start actually working problems, I hope you like these and that you're like, oh, these are pretty fun. They're not too crazy. Because the next thing we're going to do is Kramer's rule. And again, it looks kind of ugly at first, right? We're sitting here going, ooh, C1, C2, B1, B2. But remember that these are coming from equations. So the A's always go with the X's. The first equation is always all the ones. So this C comes from right here, okay? It's always the solution. So A's, B's, and C's. These guys on the top, I've got my ones. Those all come from the first equation, right? These guys on the bottom, those all have 2's in them. And they all come from the second line, right? second equation. And we're just plugging things in. So what this says is we are going to have the D guy, which is my determinant. So it's just what we've seen before, A1, A2, B1, B2. So the D equals A1, B1, A2, B2. Okay, that is just exactly what we did before. Okay, no worries there. But then we're going to add in these other determinants, okay? And they're going to be based on which variable I want to solve for, okay? So if I want to solve for the x, you see x equals here, then what I do is in the x column, I put in the answers. I still keep the B guy here, just like before, but I put in the answers. So I have something that's called the determinant for the x's. And it looks like C1 and B1 and C2 and B2, okay? And what that's telling me is this is the determinant I'm going to use on the top here. And I'm going to figure this guy out, okay? So, and then the D sub X, the determinant that goes, I'm sorry, D sub Y, the determinant that goes with the Y guy, we do exactly the opposite. We have the Y column here. We want to know what the Y value is. So we're putting in the C, the constants in there, and we keep the X thing. So it looks like A1 and C1 and A2 and C2. So basically, if we want the X, we substitute in for the X's. If we want the Y, we substitute in for the Y's. And using this D as my initial starting point, okay? So what does this guy look like? It looks kind of crazy, so I'm going to narrow it down for us. If we want our X value, we're going to do the D sub X divided by the D. That's what this says. And if we want our Y values, we're going to do some D sub Y divided by D, okay? That's not so bad, right? Okay. So what we're going to do is, as we're working through these, we are going to find each of the determinants, and then at the end, we'll find that ratio, okay? So keep this guy right here. We don't need this. Kramer's rule is just a really nice thing that tells me, hey, I can do these two ratios using determinants. And again, I don't have to deal with all the X's and Y's, all the variables and stuff like that. I can just say, hey, look here, we have some stuff going on, okay? And again, notice that all of these are going to be equations with two variables. You can do it with three variables. There is one for three variables. We are just not going to do it because it gets kind of crazy. Okay, so here is my system of equations. 5x minus 4y equals 2, and 6x minus 5y equals 1. Okay. And what I want us to do is find the determinants. There are three now, the D sub X, the D sub Y. Find them and find their values, right? Okay, so let's start with the D because he's the most straightforward. He's the one we're used to. Okay, we just did some stuff with this guy, right? It's always my A's and my B's. So 5 and -4, 6 and -5. That was a minus, right? Yeah, minus. Okay, so there's my D value. I'll come back to these other guys, okay? There's my D. Let's do that because we just did several examples of that, and hopefully we ran through them pretty quickly, right? So remember my value is, start at the top left, get that diagonal, multiply them. 5 times -5. Then the formula had a minus, so I'm going to write it in there and then do my other diagonal. 6 times -4. Okay, and this is actually going to look pretty nice for me because what this tells me is -25 minus and a minus is a plus 24. That's not a bad number, right? That's a -1. So D equals -1. That makes my life a little easy probably when I would go to do these ratios. So we'll do that in a second. Okay, D equals -1. I got a value. Okay, and then we're going to do the D sub X's, but we're going to work off of this guy. Okay, so remember, when I go to do the d sub x, and you can use the formula that I had up here a second ago, but if it confuses you with all the a sub 1s and all that stuff, don't worry about it. Just think, I'm going to solve for the x guys, right? So I'm going to substitute them with my constants, 2 and the 1, okay? The y's stay the same, -4 and -5, okay? So this is my d sub x determinant, okay? So the d sub x, I'm going to find the value the same way I just found all the other values, right? I just need to know what goes into this determinant before I do it. And I'll give you the equations, by the way. You won't have to memorize those. 2 times -5 minus, because there's a minus in the formula, minus 1 times -4. And what we get is this is equal to -10. Minus and a minus is a +4, -6. D sub x, the value for that guy is a -6, okay? And thankfully, some guy named Kramer figured out all of these ratios for us. There are proofs for this. If you wanted to see them, you could do the proofs. They're actually in the textbook, so you can look around and find those. But I don't want to do that with you. I think it's complicated, and you don't need to know what's going on behind. You just need to know how to use Kramer's rule, okay? So here we go. This is my d sub y. You can go back to the formula if you want to, but remember, I'm solving for the y guy. The x's are going to stay in there, so I leave the 5 and the 6. Okay, but I'm solving for the y guy, so now I'm going to put my c values, the 2 and the 1, those are my c's, right, in here for the y's, because I'm trying to solve for the y. So it's interesting that these are ratios that always work, no matter what kind of crazy numbers I have in my matrices. Okay, so d sub y, find that value. D sub y is equal to 5 times 1 minus, because there's a minus in the formula, 6 times 2. That's my other diagonal, right? So d sub y is 5 minus 12. That's a -7. D sub y is -7. All right. Yay, I got 3 values. Okay. So now go back to the original. Remember, it was the d over the dx to give me my x value, and the d over the dy to give me the y value. So way down here, I had those written. Okay. X is going to be I'm sorry, I said that backwards, didn't I? The dx over the d, yeah. And I think I said the d over the dx. So ignore what I said a second ago. Make sure you put the determinant that matches with the variable I'm trying to solve for on top. Okay, so I'm trying to do the dx's. I'm going to use the -6 on top, and the d on bottom is a -1. Which is why I said earlier that's going to be very nice, because anything divided by 1 is just that thing. So this is going to be 6, and a negative is a positive. So my x value is 6. Okay, got a solution there. And then for the dy dx, I do the same thing. So the dy, I'm sorry, dyd. I don't know why I'm having a hard time saying that. The 7 on top, -7, and then the d guy goes on bottom. He's a -1. And same thing. This becomes very nice for me. The negative and the negative is a positive. I get y equals 7. Okay. And your homework might ask you to give you that as a solution in a coordinate pair. So there it is. All right. Not too shabby, right? And I am not going to do tons and tons of these, because I don't want us to have to stress out about these. This will be a relatively minor portion on your final. Okay. But I need you to have seen it, and I need you to do the homework on it. So just to check yourself, here's an example you can work on your own. It says, use Kramer's rule to solve the system, and it looks like 5x plus 4y is equal to 12. I'm going to get rid of that. I don't think I need that anymore. 5x plus 4y equals 12. And 3x minus 6y is equal to 24. Remember, you're going to want to find your d, your dx, and your dy. And then to find your x, you do the dx over the d. And to find your y, you do the dy over the d. Okay, so I'm going to leave it to you to come up with all these three determinants, put them in the right order, go back and redo it, use the equation, whatever you need to do to figure that out. And then I'm going to tell you that the solution for this one, so you'll know if you did it right or not, you should get 4 and -2. So your x is a 4 and your y is a -2. So that's a practice question. So you know if you got it and you're doing it right. And again, very short video for this one, I hope, much shorter than the other one I just did. And you can use it and get this last bit of information that we need for the class, and we are done. So no new material after today. All right. Have a great break. Let me know if you need anything, if you have questions. Thanks. Bye.